We have already seen the hierarchical model. The flaws that we have seen in the hierarchical model, they try to address using the network model. The network model is a database model conceived as a flexible way of representing objects and their relationships. Its distinguishing feature is that the schema, viewed as a graph in which the object types are nodes and relationship types are arcs, is not restricted to being a hierarchy or lattice. The network model is useful for representing such records that have many-to-many relationships, unlike the hierarchical data model wherein we only have one-to-many relationships. Just like what we have said, the network models are created to represent complex data relationships effectively. This has led to improved database performance and impose a database standard. If you can recall, in the hierarchical model, we don't have a standard yet. It also allows a record to have more than one parent. Now, there are standard database concepts that emerge with the network model, and they are still used by modern data models. These are the schema and subschema, the data manipulation language, and the data definition language. The following are the advantages of network model. First, conceptually, it is simple. It can handle more relationship types. The data access is also flexible. The data owner and member relationship promotes data integrity. We now have standards that we need to conform to, and it also includes data definition language and data manipulation language. For the disadvantages, there is still some system complexity, which limits the efficiency of the model. We also have navigational system, which yields complex implementation, application development, and management. And if we have structural changes, we are going to require changes in all application programs accessing our database. Next is the relational data model. In relational model, the data and relationships are represented by a collection of interrelated tables, and that connection is represented by keys, such as in this example. Now, each table is a group of column and rows, where column represents attribute of an entity, and the rows represents the records. The relational model produces an automatic transmission database that replaces standard transmission databases. It is based on a relation, in other words, tables, which is a matrix composed of intersecting tuples or rows and attributes, which are the columns. It describes a precise set of data manipulation constructs. For the relational database model, we have RDBMS or Relational Database Management Systems. These systems perform basic functions provided by the hierarchical and network DBMS systems as well, and it makes the relational data model easier to understand and implement because it hides the complexities of the relational model from the user. In an SQL-based relational database application, we have the following components. We can see an end-user interface, which allows the end user to interact with the data. We also have a collection of tables stored in the database, where each table is independent from another, and the rows in different tables are related based on common values in common attributes. In this case, these are called keys. And we also have an SQL engine, which executes all of our queries for us to fetch data from our database. For the advantages of the relational model, the structural independence is promoted using independent tables. We also have tabular view, which improves the conceptual simplicity. We also have ad hoc query capability that is based on SQL. It also isolates the end user from physical level details and improves implementation and management simplicity. On the other hand, for the disadvantages, we have the following. It requires substantial hardware and system software overhead. The conceptual simplicity gives untrained people the tools to use a good system poorly, and it may promote information problems. Next is the entity relationship model, which is a graphical representation of entities and their relationships in a database structure. We will have a more thorough discussion of this in our laboratory. It uses graphical representations to model the database components. In an entity relationship diagram, we have the entity instance or entity occurrence, attributes, and connectivity. The entity instance or entity occurrence are translated into rows in our relational table. For the attributes, they are describing the particular characteristics of our entities, and for the connectivity, this is the term that we are using to label the relationship types. The following are the entity relationship model notations. We have the chain notation, the crowsfoot notation, and the UML class diagram notation. We will be discussing each of the notation for each of the relationship type that we have. One-to-many, many-to-many, and one-to-one. Let us start with one-to-many. Let us take, for example, two entities. We have the painter entity and the painting entity. In considering the relationship between these two entities, we again take a look at them bidirectionally. Meaning we start with one and go to the other, and then from the another, going back to the other one. Let's start with the painter. We ask the question, how many instances for each instance of the painter, how many instances of the painting can they have? And the answer to that is many. A painter can paint many paintings. Whereas, on the other hand, if you start with the painting, how many painting, for each instance of the painting, how many painters could have painted the painting? And the answer to that is 1. And so we have one on one end and many on the other end. Hence, we have a one-to-many relationship. Now, in this notation, in the chain notation, you can see that the entities are represented by squares or rectangles, and the relationship is represented by the line in between them, wherein we are capturing the verb that captures the relationship in the diamond in between the entities. And lastly, the number 1 on the painter side represents that it is the one part in the one-to-many, and the M represents the many part in the one-to-many relationship. In the crowsfoot notation, it's more or less the same. We are still going to use our rectangle for our entities, but for the relationships, they are represented by a crowsfoot notation, wherein, as you can see, we still have the verb, but the ends of the connector looks like a crowsfoot if it is on the many part, and just two lines if it is on the one part. We'll be discussing more of these later. And lastly, for the UML class diagram notation, it's still the same. We have rectangles for the entities, but for the relationship, they are represented by a line. And as you can see, the main difference is that we have two verbs that captures which verb is used from one entity to another. Like for example, the painter paints the painting, and so the paints is near the painter. Whereas the painted by is near the painting because the painting is painted by the painter. And lastly, you will notice that there is a 1 dot dot 1 and 1 dot dot asterisk. The 1 dot dot 1 specifies that it is the one part, and the 1 dot dot asterisk represents that it is the many part. For the many-to-many type of relationship, it's still more or less the same, except that for the chain notation, we are going to make use of n to represent the other part of the many. For the crowsfoot notation, we are going to put both crowsfoot on either sides. And same with the UML class diagram notation. We are going to make use of 1 dot dot asterisk for both sides. And same goes with the one-to-one relation. Instead of using M or N for the chain notation, we're just going to make use of 1. For the crowsfoot, we're just going to make use of 2 lines for both ends. And for the UML class diagram notation, we're going to make use of 1 dot dot 1 on both ends. For the advantages, we have the following. First, the visual modeling yields conceptual simplicity. Second, the visual representation makes it an effective communication tool. And lastly, it is integrated with the dominant relational model. For the disadvantages, it has limited constraint representation, also has limited relationship representation. We also don't have data manipulation language, and the loss of information content occurs when attributes are removed from entities to avoid crowded displays. And as we have seen in the previous 3 examples of the entity relationship diagram, we have omitted the attributes from our diagram.